Chapter 5 is going to be dealing with inequalities, okay? We first start with solving inequalities with addition and subtraction. All right, again, we've done these before, so this is not brand new to you. We're going over them again. So we're going to be having inequalities with addition and subtraction, multiplication and division, multi-step inequalities. Then we're going to get compound inequalities. That's new. All right, we will start that together next week, okay? So compound inequalities, we're going to be looking at absolute value equations, absolute value inequalities, all right, and then we're going to be looking at inequalities where we have two variables. So all of this chapter, with the exception of the last section, is just going to have one variable in it. 3x plus y is less than or equal to 1. All right, stuff that looks like that. The compound inequality stuff and the absolute value inequality stuff, that stuff's new. That's at the end of the chapter, or at the end of the chapter. That's 5, 6, and 7, those sections, okay? So that's kind of where we're going, all right? So let's just jump into the beginning of this. All right, so today is the 15th. Good Lord. We are looking at Chapter 5, Section 1. All right, and what we're going to do is we are going to solve inequalities using addition and subtraction. Tonight's homework should be pretty easy for you guys because we've done this before. All right, we don't do it all that often, otherwise I would skip this, but I want to make sure that you guys are on solid ground with this. All right, you do need your rulers, so take a moment right now real quick to get your compass out or your ruler out. Okay. All right, so let's talk about the graph of an inequality. Inequality might look something like x plus 1 is less than 5. That's an inequality. All right, when we talk about the solution, and we're going to be doing these in class. Remember, we solve these exactly like we would an equation. This is a super easy one. I'm going to add -1 to each side. So x is less than 4. So this, if you remember, this is what a solution looks like. All right, since we have one variable, we graph on a number line. So since we have one variable, we graph on a number line. And let's talk about what we are graphing. All right, the first thing that we graph is our dot. Remember, we have an open dot. And then I'm going to drop down a little bit here because I'm going to put some information there. And we have a closed dot. What inequality symbols go with an open dot? What inequality symbols go with an open dot? L? Slow down. Does the equal to go with this? With an open dot? No. So it's a less than symbol or a greater than symbol. All right, if you remember, this is something I want to make sure we remember. When we look at the example of our solution, remember, I call that 4, that number that's in the solution, I call that our start number, because that's where our solution starts from, is at that point. So when I refer to our start number, that's what I'm talking about. When we go to our solution, the number that's in our solution is called our start number. Yes? What? Are you okay? No, I want you checking me. That's okay. You're all good. All right, so that is called our start number. That's where our solution starts from, okay? Joseph? So an open dot, what that solution means is the start number is not part of the solution. Our solution is to start there. That's why it's called the start number. So an open dot means that it's not part of the solution. If we go back up and say x is less than 4, well, x is less than 4. It's not equal to 4. So we would put an open dot at 4 to show that's where our solutions start from, but it doesn't include 4. All right. A closed dot is a less than or equal to or a greater than or equal to. So the closed dot has the equal to as well. So what that means is the start number is part of the solution. So an open dot is less than or greater than, which means the start number is not part of the solution. A closed dot is when we have less than or equal to or greater than or equal to, and it is part of the solution. How many of you guys kind of remember this from last year? Okay. What's the other thing we graph except for just the dot of the solution? Lily? Be more specific. Yep, I call that the shading, but it is. You can make it a line. So I call that our shading. But you're right, Lily, that's exactly what it is. All right, the shading is it's all the possible solutions from the start number. So it's the direction that all the possible solutions are going to be going. So if we look at x is less than 4, I'm just going to do that right here underneath all of this. I have my number line. I try and always find my 0 so I can figure out where I am, and also so I know what I'm counting by. Please draw the number line. All right, the last, not this past test, but previous test when we've been graphing, you guys, some of you have not been drawing your axes or your number lines. Draw the number line, please. Put your increments on there. Put at least 1 on each side of your 0. If you're counting by ones, I don't need to see what you're counting by. If you're counting by something other than ones, I want to see on either side of your 0 what you're counting by. So if I was counting by 2s, I would have -2 and +2 on here, and then my start number. All right, well, my start number is 4. Here's 4. It's an open dot at 4, and all my x's are less than 4, so I'm just going to shade to the left of 4. You guys cool with that? Okay. All right, so let's just go into solving these. Who needs to see what's up there? Okay. So I want you guys to solve and graph. Let's talk about solving these inequalities. Let's talk about solving inequalities. When we have addition and subtraction, just want to remind you of this, the process is exactly the same as equations. So when you have addition and subtraction, it's exactly the same as equations. Multiplication and division are not exactly the same. All right, so I'm going to give you a couple of these to solve. So I want you to solve and graph. All right, we are going to talk about checking the solution. So when we're done with this problem, we're going to talk about checking it. All right, so here is my first example. X minus 5 is equal to negative 3.5. Go ahead and solve that, please. Oh, heaven forbid. I love that you keep me honest. Let's do greater than. Thank you, sweetheart. Yes, if it was equal to, you would just put a dot there. Yes, so thank you for making me think again. Joseph, do you just randomly just sit there talking while you're working? But don't you think that Seamus kind of wants to try and figure that out for himself? Maybe. Why don't you wait till you're done until you start conferring with each other? Okay. Alright, so you guys all should know we're going to add 5 to each side. So I have x is greater than, well I have 5, well you guys will use your calculators. That should be 1.5 if I did that right. So 5 minus 3.5 is going to give me 1.5. So x is equal to a positive 1.5. So I'm going to put my 0 right here. I'm actually going to count by 0.5s. Because there's no reason I can't. It'll fit on my graph. So as you can see, I'm just showing negative 0.5 on one side of the 0, 0.5 on the other. And then here's my 1.5. Should that be an open dot or a closed dot on 1.5? Rita? Should be an open dot. Now here's the thing. Before you start outsmarting yourselves, let me remind you. That inequality symbol is not pointing in the direction of the shading unless the variable is coming first like it is here. When that variable is on the left-hand side and the constant's on the right-hand side, that inequality symbol is facing the direction you should be shading. But when you have the reverse and the variable is on the right and the constant's on the left, it's not. All right? So just be really careful if that's something that you're using as kind of like a indication as to which way to shade. I always just say, what are all my x's in relation to my start number? All right, so Rita, what are they all? They're greater, so I'm going to do everything to the right. Just somehow shade, have the end be an arrow. You don't have to take your shading to the end of your number line, just long enough that I can see what direction you're shading and there's an arrow. How many of you guys remember doing this? Okay, so let's talk about checking the solution. You don't have to unless they ask you to in your homework. All right, this checking your solution is different for equations than for inequalities. For an equation, you're actually checking. If this was x equals, then this would be x equals 1.5. We would just substitute that 1.5 in for x and see if it equals or y, or equals the other side. Here, that's not what we're doing, because that 1.5 is our start number. It's not going to make that solution, this inequality, true. We don't ever want to use our start number. All right, the start number, if you were to put that in, all that's doing is deciding if you have the right dot or not. All right, so what we're actually doing is we're checking the shading. So all we're doing is really checking the shading. So what you want to do is just choose any number in shaded area to see if it makes inequality true. If it does, you shaded right. If yes, shading correct. If it's no, switch your shading. So all we're looking for is to see is the number that you're choosing, is it in the shaded area? So it really does not matter what number you choose. So I'm just going to choose 2 just because it's easy. So I'm going to check if x equals 2. So if I have 2 plus a negative 5, I'm looking to see is that greater than negative 3.5. All right, well negative 3, is that greater than negative 3.5? Is negative 3 greater than negative 3.5? What do you guys think? Yeah, this is true. So my solution is correct. I'm going to say true. So x is greater than 1.5 is correct. That's really what you just proved. That shading is correct. You guys cool so far? Okay. I'm going to give you a couple that I want you to work on. Who needs to see what's up there? Okay. Remember I told you these aren't going to be that hard. Alright, so let me give you a couple. I want you to solve, graph, and check. Here's my first one. 9 is greater than or equal to x plus 7. There's my first one. Go ahead and get going on that. So there are the 2 that I want you guys to do for now. When you're done, check with someone sitting by you. All right, someone tell me how to solve that first one. Hello? Someone tell me how to solve that first one. Rafaela? Okay. Excellent. Did you reverse that, or did you leave it like that? Excellent. You can reverse it if you want. It doesn't bother me. All right, so I'm doing my number line. Here's my 0. All right, so what am I going to do from here, Rafael? Awesome. Why is it closed? Yep. Nice. So my shading's going to go to the left. How many of you guys got that? Awesome. All right, somebody do my second one for me. Molly? Okay. Okay, so first what I need to do is I need to change this into the same denominator, right? Yeah. So I'm going to show that work here somewhere. So I end up with 4, nope, I end up with 2/4, right? So this is 2/4. I should see this somewhere, and I'm adding to that my 3/4. So I end up with 5/4. Or 1 1/4. So don't forget to do that equivalent fraction work. All right. So now I'm going to go ahead and graph that. So tell me what I'm going to do now.
So I want my 1/4. So you're going to put a 0 somewhere, and then those extra halves are 1/4 and 1/4. And then you count up to 1 1/4.
So here's my 0. So 1, 2, 3, 4. So this would be 1 1/4 here, right?
Yeah.
Because there's 1.
It'll be close that because it's equal to, it's more than equal.
Yep.
And then I shade it to the right.
Excellent. How many of you guys are cool with those? Awesome. All right. Story problems. What are you anticipating, or what should you be looking for in a story problem to indicate it's an inequality versus an equation? So think about reading through a story problem and tell me, what would you think wording you're going to see, and it's more than one thing, that would indicate an inequality versus an equation? Al? Right? At least or at most? Absolutely. What else could you look for? Brian? Greater than or less than? Yep. Mia? More than or equal to? Rafaela? Starting at? Maximum, minimum? All right. All the possible solutions, right? That also would indicate it. Mostly it is the maximum or minimum, are at the greatest or at the least or at the most. Those are what you're looking for. All right. So we're looking for at least, no more than, a maximum of, and these take the place of is. I'm going to say instead of is. The answer is. The total number of people is versus the total number of people are at least. All right. Inequalities are one of the reasons I'm super picky on parts equal to your whole, because when we have our parts, that is our actual work, and our whole is either our maximum or our minimum goal. So it's really important that you use that as your guide. It's always parts equal to your whole. Your whole is always a maximum or minimum goal, and then your parts are the stuff that you're actually doing. And we want to know what we're actually doing in relation to our maximum. What are we actually doing in relation to our minimum? Do you guys remember this a little bit from last year? All right, I'm going to put a story problem up. I want you guys to do it, okay?
We have Madison Gorska to do our afternoon prayer.
Dear God, thank you for blessing the church and everything in this world. You are the creator, and I love you, and I thank you for this amazing world. Thank you for all of my wonderful blessings and for letting me have such a wonderful life. Please help me to pray for those who are in heaven and let them know we think of them every day. Help me to be a better sister and a better friend. I am so sorry for disobeying you sometimes. Please forgive me. Thank you. Go pray for us.
That was sweet.
Great job, Madison. We do have a few lost and found items in the office. If you are missing an AirPod holder, there is an AirPod holder
All right, get
down
going,
in the
guys.
main office. If you are missing a necklace with what looks to be some initials, possibly WLC or something to that effect, if you're missing a necklace with an engraving in it. And finally, we do have a wallet that we've had down in the office for a few days, which is a flowery wallet with some money in it. If that belongs to you, please come down to the main office now. I'd like to wish a happy birthday today to Mr. Bruce Shevitz, our athletic director. Happy birthday today, Mr. Bruce Shevitz. Happy birthday today to second grade student Dylan Hakem. Happy birthday today, Dylan. And to first grade student Hajun Lee. Hajun, happy birthday today. Happy birthday today, Dylan and Hajun. Those are your announcements for this Wednesday. Have a wonderful rest of your Wednesday. Thank you.
So if you notice on this one, you see a couple things on there. You see the bag can weigh no more than 50 pounds versus the bag can weigh 50 pounds. If it said the bag can weigh 50 pounds, that's an equation. Since it says the bag can weigh no more than 50 pounds, that makes it an inequality. Also, it says find the possible weights. That's another indication that it's an inequality. If this was an equation, it would say find the weight that we could add. So look for those telltale signs in the words. You don't have to check your answer here. Yep. Yes. Always for story problems when you're setting up an equation or an inequality. The only ones you don't need game plans for are like proportions, greatest common factor, least common multiple, because you're really not setting up equations necessarily for that. And for proportions, your percentage equation, if it's percents, is your game plan. Not if it doesn't make sense. I mean, if you're up in like the 40s or 50s or 60s or something like that, then you probably can't. So if you don't think you can fit 0 on there, put more than just your number. Put a couple numbers on either side of it so I know where you are and what you're counting by. It's a good question. Somebody write my equation for me. Whose voice have I not heard? Ashley, go ahead. Dude, you need a game plan. Okay, hang on a second. So your total weight has to be less or equal to your initial weight plus the weight added. Excellent. And then go ahead, sweetie. Excellent. Awesome. All right, if I was to graph that, and then normally for these we're not going to graph. I know I said graph, but so we'll practice graphing it. But then for these, we definitely want to explain our answer. So let's graph it first. If they don't say graph, don't graph. All right, so Ashley, I'm just going to put like, I'm going to put 33, and I'm going to count by 0.5s. So here is 34. What? Oh, what's the problem? Okay, so should it be equal to? So that's a good question. So let's think about that. I'm not thinking about that right now. Thank you for questioning this. So this inequality right here, let's go back and let's rewind something for a second. Is this total weight our maximum or our minimum? We definitely need to figure that out first. Ryan? That's our maximum. So what does our actual have to be in relation to our maximum? Can it be more than our maximum or less than our maximum? Ryan? Has to be less than. So I totally agree with you. We need to flip this. That's part of what I needed to be doing with you. And you guys, I just totally dropped that ball. So thank you for making sure I'm honest with this. All right, so what we are actually doing has to be less than that maximum. So always determine if your total is a maximum or a minimum, and then what our actual has to be from there. Thank you so much, you guys. All right, so here's my 33, here's my 34. I'm counting by 0.5s. So my 32, or 33.2 is going to be somewhere in here. It's closed dot. And it's going to be everything to the right of that. Somebody explain what my answer means. Remember, you have to have a sentence that goes with this. What does my answer actually mean? Joseph? No, that's not what it means. Yep, the additional weight. Say it again. The additional weight we can add is what, Joseph? No. Not exactly. Somebody word that properly. Lily? Exactly. It's at most 33.2 pounds. You can't say is, exactly. Because that's an equation, that's not an inequality. So it's at most. I would, one way to make sure that you word that properly is use the same words they have. I mean, go back up and look at the words they use. That's a good way to make sure that you use the right inequality statement, like that phrasing, because our weight that we're adding can be no more than 33.2. That will always be the case, that whatever wording they use should be the wording you can also use in your solution. Does that make sense to you guys? Al, you have that look on your face again. You can say is. You just can't say it. Like what Joseph said is the additional weight is 33.2 pounds. But that's not true. The additional weight is at most 33. So it's not that you are never going to use the word is. It's just that it's not just is. It's at most, or it is at least, or it is no more than. Does that make sense? So you can have the word is in there. It just has to go with your inequality phrase as well. Does that make sense? Excellent. Molly?
So for the numbers that are like really far away from zero, like 33.2, do you not have to put the zero on the graph?
No, who just asked me that? Yeah, so Al asked earlier. No, if you can't find zero, because the numbers, I mean, if we were counting, if this was exactly 30, I could probably count by tens and it would be fine. Usually, story problems aren't necessarily going to make you graph. I just wanted to get you guys practice in graphing, but story problems typically don't make you graph. You do have to state your answer. So I should see your solution, and then I should see your sentence that goes with your solution. So always explain the answer when you are done, please. Do you guys remember doing this last year? So you guys pretty cool with this? Awesome. Then we're good to go. So Giselle, you didn't miss, I mean, you missed a class, but we